Hello again. Let's talk about the next mini project which I'm going to talk about. Now, custom OBD-II scam tool development using ELM327. All right. So, how are you going to develop a customized OBD-II scan tool? Now, first is to design. What is the project objective? To design and implement a custom scan tool application using ELM327 OBD-II adapter, which is capable of. And what is the purpose of the scan tool? What are all the major objectives that scan tool application should be capable of fulfilling? First is it should read live vehicle parameters, RPM, coolant temperature, etc. Reading and clearing diagnostic trouble codes, monitoring fuel efficiency and emissions, reforming basic diagnostic tests via mod 01 and mod 03, running on Windows, Android, web using serial communication, for example, Bluetooth or USB or Wi-Fi. Now, these are all the various objectives that must be fulfilled and this is the objective for which this custom scan tool is being developed. So, how do you go about it? First step is you have to identify the hardware and protocol background. All right. So first you take a ELM327 chip, a low-cost OBD2 interpreter internal circuit developed by ELM Electronics. Next, it converts OBD2 commands into human readable ASIC2 messages, converts multiple OBD tools, ISO 15765, ISO 91412, ISO 142304, SAE J1850. All right. So these is the first step. You identify a tool which supports all this OBD protocols. Next is when it comes to the vehicle side, you use a J1962 16-pin connector. We have discussed extensively about the 16-pin connector. Now this is the connector that needs to be integrated into the vehicle, and it communicates with ECU over CAN bus. All right, communicates with ECU over CAN bus in most modern, as it happens in the most modern vehicles. Now talking about the software setup, next is what is the development stack? What are the various languages we use? First language is Python, Java for Android, JavaScript for Web Serial API. And when it comes to interface, USB Serial, Bluetooth, Wi-Fi. And when it comes to libraries, Python library, which includes PySerial, Tinker for GUI, and PyQt5. Next is Android, Bluetooth socket and serial APIs. And JavaScript Web Bluetooth or Web Serial API. Now, what are the various OBD2 functional modes used? Now, mode, description, usage in tools. Now, when it comes to mode, show current data, which includes the PIDs, the probability, the potential probability identification. And next is read live data. When it comes to mod 3, request to store DTCs, and with the help of this step, you show mill DTCs. And next is you clear DTCs. Mod 4 means clear DTCs and mill, reset check engine. And mode 09 request vehicle info when win ECU ID and calibration ID. Okay, so these are the OBD2 functional modes used. And what are the common PIDs used? Okay, PID okay, here we are going to see PID parameter and formula. All right, PID means the first PID 0C means engine RPM, and the formula is A star 256 plus B by 4. And next is PID is OD vehicle speed A kilometer per hour, 05 coolant temperature A40, and 0F intake air temperature A40, and 10 MAF mass airflow. Again the formula is A into 256 plus B divided by 100. Now what are the various implementation steps? Now first implementation step is you connect to the tool ELM, hypothetical tool ELM327, and discover the communication port or Bluetooth address. Open serial communication default baud 38400 or 9600, and send ELM327 ATZ reset, ATE0 echo off, ATL0 line feeds off, ATH0 headers off, and ATSP0 automatic protocol. And what is the second step? Request live data. Send 010C /R for RPM. Receive response as mentioned here. And next is you read the DTC with the help of sending the correct command and receiving the correct response. Next, when you clear the DTCs, again you send the right command which clears the MIL and clear DTCs. Next comes the GUI design. Now live graphs of RPM, coolant temperature, freeze frame data, mill status and trouble code viewer, and button includes clear codes, refresh, vehicle info. So these are the buttons that need to be added in the graphic user interface. Now when it comes to ELM327 327 command flow diagram. This is the command flow diagram. User action, API user interface, send OBD-II command. With the help of the scan tool, you connect the ECU, you contact the ECU with the help of CAN, then you get the response and which is displayed. All right. Now this step by step is the step by step procedure for the command flow diagram. Okay, so these are the steps one after the other, that is which is followed to ensure that commands are being processed. Now what are the challenges faced? Challenges faced is issue resolution. Some parameter identifications are not supported. For example, handle no data gracefully and hide unsupported data. And Bluetooth pairing issues, prompt user for manual pairing or MAC address entry. Now, when it comes to slow refresh rates, optimize loop and use asynchronous reading. Now, when it comes to vehicle identification number retrieval fails. Now, this is a major issue that needs to be addressed. Sometimes you have to use the mode 09 PID02 and retry if no response. All right. Now, this is the solution. Using this mode is the solution. And even if that is not working, you have to retry. That's the only solution for this particular challenge. Now talking about the outcome, successfully developed a portable cost-effective scan tool for DIY diagnostics, learning CAN and OBD-II protocols. Now reading real-time parameters, monitoring fuel and emissions. All right, so this is the outcome of this entire project. Now, what are the major advanced feature suggestions? Some other features like freeze frame data can be added into the scan tool. Emission monitors can be added. Fuel trim and lambda control can be added. Trip logging and graphing using SQLite or CSV can be added. Export diagnostic reports can be added. Fault code injections and lookup from SAE J2012 database, and integration with GPS for telematics logging. Now talking about the sample Python code snippet. Now this is a sample Python code snippet, which is a small screenshot which I have placed here. If you want, you can use it directly in any application. All right. Now the final outcome is practical knowledge of OBD-II modes and PIDs, experience working with serial. Now by completing this project, these are all the practical learning experience the doer can derive out of it. Next is experience working with serial communication protocols, developed a real world automotive diagnostic tools, gained exposure to CAN based communication, and reinforced understanding of DTC structures and ELM327 command test. All right. So these are the various kinds of learning outcomes that need to be learned by a learner who has completed this project.